Tomorrow we will have our quiz over 1.1 to 1.3. If you are an e-learner, please remember that you must take your assigned quiz during your geometry period. So for example, if you are supposed to be in my first period geometry class, you should be taking the quiz from 7:40 to 8:31. There are no excuses. If you have any questions about that, please email me right away. All right, so here is the study guide for our quiz. Remember, you can use this on the quiz tomorrow. So number 1, the notion for the length of a segment between A and B is, all right, so we want to look for the symbol that represents a segment. A segment has endpoints. So right away I can get rid of answer choice B because that is a line, and answer choice D because that represents a ray. So now I'm between choices A and C, and the correct answer is C because I see that segment above AB. Answer choice A is not an answer because it doesn't show us anything. 2, C, D, and E are collinear. C is between D and E. DC is equal to 3V plus 30, and CE is equal to 6V minus 15, and DE is equal to 60. I need to solve for V and then determine the length of segment CE. All right, the first thing I want to do here is kind of sketch out a picture. I'm going to apologize ahead of time. It's hard to write on this computer. So I have D is one endpoint, E is the other endpoint, and C is somewhere in between. It is not in the middle. I'll say that again. It is not in the middle. It's just somewhere in between. So DC is equal to 3V plus 30. CE is 6V minus 15. And I know CE is equal to 60. Now that I have my picture, let's set up my equation. I'm going to use the segment addition postulate here, which states that one part plus the other part is equal to the entire segment. So the first part is 3V plus 30 plus the second part, which is 6V minus 15, is equal to the entire segment, which we know is equal to 60. All right, so let's combine our like terms. 3V and 6V is 9V. 30 minus 15 is going to be a positive 15. That's equal to 60. Subtract 15 from each side. I then have 9V is equal to 45. So that means then V is equal to 5. Next, I need to figure out what is the length of CE. So I see that CE is the equation 6V minus 15, and I know V is 5, so let's plug that all in. So 6 times 5 minus 15. And if I plug that in, I end up getting 15. That's an equal sign. So my answer is 15. 3, M is the midpoint of the segment. Find length CG. So this problem is different because then I know M is the midpoint. Midpoint means point in the middle. So if M is in the middle of CG, I then know that CM is the same length as MG. So what do I do here? I'm just going to set those two equations equal to each other. So 4x minus 5 is equal to 2x plus 7 minus 2x on each side. I end up getting 2x minus 5 is equal to 7. Add 5 to each side. 2x is equal to 12. Divide by 2. X is equal to 6. All right, the last part here says find CG. So here's my equation for CG. So if I plug this in, 4 times 6 minus 5, I end up getting 19. Now let's look for MG. That should also be 19, but let's just double check. So if I plug in 2 times 6 plus 7, I do get 19, so those match. That is great. They should be the same. So what is the length of the entire segment? Well, if this is 19 and this is 19, I just add that up. So 19 plus 19 is equal to 38. So my final answer then is 38. Give another name for ray AC. All right, so if I look at my diagram, I know that the endpoint should be by A, and my arrowhead is going to be towards C. Now remember, arrowheads mean that they go on forever and ever and ever, so that means I can extend this a little bit if I would like to. So that means that ray AB is another name for ray AC. So I'm going to draw a ray and AB. Give another name for segment BD. If I look at BD, a segment stops. And so the only name I could use here is actually by flipping my points around. So another name for segment BD would be segment DB. So let's switch D and B around, and don't forget your segment mark. Name the 3 geometric undefined terms given in this textbook, or that we learned in class. This goes back to 1-1. So the 3 geometric undefined terms are point, line, and plane. This just means that these have no formal definition, but these are terms that are widely known. 6. Find the midpoint of the segment with endpoints -9, 6, and 8, -7. All right, so first I'm going to write down our midpoint formula. And our midpoint formula is x2 plus x1 divided by 2. That's how you find the x-coordinate. And y2 plus y1 over 2. That's how you find the y-coordinate. Now going back into my 2 coordinates that I am given, -9, 6 is the first coordinate, so I'm just going to call that guy x1, y1. 8, -7 is my second coordinate, so I'm going to call that x2, y2. So now I'm going to plug those coordinates into my equation. So x2 is 8 plus x1, which is -9 over 2. y2 is -7 plus y1, which is 6. Divide that by 2. So if I plug 8 plus -9 divided by 2 in my calculator, that's for my x-coordinate, I end up getting -1/2. If I plug in -7 plus 6, divide all that by 2 in my calculator, I also get -1/2. So my midpoint coordinate then is -1/2, -1/2. Number 7, find the distance between points D and E. There are a couple ways we could do this. We could use the distance formula, or I can use the Pythagorean theorem. The Pythagorean theorem is actually what I'm going to use here, but before I can use the Pythagorean theorem, I need to draw out a triangle. So to get from D to E, I'm going to draw a very bad line, but just a line from D to E. So now I need to make a right triangle. And that's good enough, okay? So I need to figure out what is the length of that triangle. So I don't know what that point is called because it's not actually a point on the graph. But if I start at this point here, hopefully you can see me highlighting it. I go up 1, 2, 3, 4. So that length of the triangle is 4. Back to the unnamed dot, if I go from that dot to E, it's only one space. And I need to figure out what is the length of DE, so I'll call that X. So let's look at the Pythagorean theorem. A squared plus B squared is equal to C squared. From my diagram, I'm going to call A 4. So I have 4 squared plus, I'm going to call B 1, B squared, and I'm going to call C X, X squared. So I need to solve for X. So if I plug this in my calculator, 4 squared is 16, 1 squared is 1, is equal to X squared. 16 plus 1 is 17. And I still have X squared, but I don't care about what X squared is equal to. I want to know what is X equal to. So to get rid of the squared with my X, that means I have to do the square root of each side. So square root, square root. So the square root of 17 is equal to X. Or if I wanted to approximate this, I could say 4.1. Next, I want to give another name for plane V. So if I look at my diagram, plane V is the blue plane or the blue figure. To name a plane, I need at least 3 points that are not collinear. So there's a bunch of different names I could use. So for example, I could say that this is plane R, T, and S. So R, T, S are non-collinear and they're on the plane. Let's do one more. Plane actually, that looks like that would be it. Those are the only points. So I'll erase that. Just plain RTS. Actually, that is a lie. Plain. How about QST? That one works too. QST are not collinear and they're on the plane. All right, our next problem. If AB is equal to 12, AC is equal to 29, find the length of BC. All right, so some parts are already labeled here. So AB is 12. I also know that AC is equal to 29. I need to solve for X. I'm going to use the segment addition postulate for this. So the part plus the part equals the whole. So one part is 12. The other part is X. The entire segment is equal to 29. So to solve for X, I just need to subtract 12 on each side. So X is equal to 17. And so BC then is equal to 17. 9. Name the intersection of plane EFQ and plane FGS. All right, so I need to sort of outline or highlight my plane. So plane EFQ. I see E here, EFQ. So this is the plane that I am looking at. The second plane is plane FGS. FGS. All right, so remember, when two planes intersect, their intersection is going to be a line. So right away I can write line, but what line is it? It's going to be this line right here. That is where those two planes collide, and I can call that line FQ, or if you flip-flop that and call it line QF, that is also the correct answer. Are the points coplanar? Well, first, what does coplanar mean? Coplanar means points on the same plane. So I'm going to start with F, and I'll highlight it. G, S, and Q. Are those on the same plane? The answer is yes. How about E, H, P, Q? So I have E, H, P, and Q. All right, so are those points on the same plane? The answer is no. And the easiest way to kind of see this is H and Q definitely are not on the same plane. There's no way that they could be. So that is the reason that they are not in the same plane. And lastly, E, H, Q, S. So E is here, H is here, Q is over here, and S is here. So once again, this is going to be no. And just like what we said before, H and Q are not on the same plane right away. Same thing with E and Q. Those are not on the same plane. They're opposites. So right away we know that those points are not coplanar.